Hi and Assalamualaikum to Puan Azalina.
Today we want to present our case study
About foundation failure in Penang.
Under code COSTI CC30093 Geotechnical Engineering.
Hi, my name is Nur Anisa Nasir binti Muhammad Rosli and my metric number is 16 DKA 22F1061.
Hi, my name is Nur Ainur Madi binti Mazlan and my matrix number is 16 DKA 22F1007.
Hi, my name is Muhammad Faiman bin Ahmad Salimi. My metric number is 16 DKA 22F1064.
Hi, my name is Muhammad Izzat Nazran bin Muhammad Zaki. My matrix number is 16 DKA 22F1049.
And this is my group member.
Foundation is the element of a structure that serves to support the load, and it is the lowest part of the building or the civil structure that is in direct contact with the soil, which transfer load from the structure to the soil safely. Generally, the foundation can be classified into, namely shallow foundation and deep foundation. A shallow foundation transfers the load to a stratum present in a shallow depth. The depth foundation transfers the load to a deeper depth below the ground surface. A tall building like a skyscraper or a building constructed on very weak soil require deep foundation. If the construct building has the plan to extend vertically in future, then a deep foundation must be suggested. Next is purpose of foundation. Foundation is the main reason behind the stability of any structure. Without the foundation bed being strong, it is bound to fall. The stronger is the foundation, the more stable is the structure. Next, the proper design and construction of foundation provide a proper surface for the development of the substructure in a proper level and over a firm bed. Then, design foundation help in avoid the lateral movement of the supporting material. After that, a proper foundation distribute load on the surface of the bed uniformly. This uniform transfer help in avoiding unequal settlement of the building. Differential settlement is an undesirable building effect. Also, the foundation serves the purpose of completely distributing the load from the surface over a large base area and then to the soil underneath. This load transferred to the soil should be within the allowable bearing capacity of the soil. Function of the foundation. Based on the purpose of foundation in construction, the main function of the foundation are reduction of load intensity. The foundation distributes the load of the superstructure to a larger area so that the intensity of the load at its base does not exceed the safe bearing capacity of the subsoil. Next, even distribution of load is the function of the foundation to distribute the non-uniform load of the superstructure evenly to the subsoil. For example, two columns carrying equal load can have a combined footing which may transmit the load to the subsoil evenly with uniform soil pressure. Due to this, unequal or differential settlement are minimized. Also, lateral stability is an anchor the superstructure to the ground, thus imparting lateral stability to the superstructure. The stability of the building against sliding and overturning due to horizontal force such as wind, earthquake, it is increased due to foundation. After that, it is to provide the structure safely against undermining or scoring due to boring animal and flood water. Lastly, protection against soil movement is special for foundation measure prevent or minimize the distress or cracks in the superstructure due to expansion or contraction of the subsoil because of moisture movement in some problematic soil.
I want to explain about discussion foundation failure in Penang. Fort Cornwallis, which was built in 1810, has a significant role in the history of Penang Island, Malaysia. Gazetted in 1977 under Antiquities Act 1976. The fort is considered as an important monument and landmark in the historical development of Malaysia. In March 2000, the Malaysian government, through the Department of Museums and Antiquity, had granted a total sum of ringgit 2.1 million in USD 0.5 million for the restoration of the Fort Cornwallis. The project was carried out in 2 stages. The first stage included building defect diagnosis, structural analysis, application of proven conservation method and technique, as well as recording and documentation. Stage 2 include the reconstruction of the demolished fort west wall. This focuses on some major structural defects of the Fort Cornwallis and some methods and techniques used in handling the building defects. It also discussed some issues and problems related to the project. Restoration works were carried out over a period of 1 year and was completed in March 2001. They assist and monitor the project progress. A team of consultants, including structural engineer and conservation consultant, were appointed by the government. Other professionals, including quantity surveyor, archaeology, microbiology, geology, and electrical engineer were also aided in providing expert advice on specific method and technique employed during the project.
Historical background.
Upon taking possession of the Penang Island from the Sultan of Kedah in 1786, British Captain Sir Francis Light built the Fort Cornwallis, covering an area of 470.6 feet. It was rebuilt in 1804 with bricks and stone by Indian convict labor during Colonel R.T. Farquhar's tenure as Governor of Penang. It was then completed in 1810 during Norman McAllister's term as Governor of Penang at a cost of 18,000. The cover an area of 332 and 859 feet. It is entirely historic. The fort had never been aged in any battle. Its function was more administrative rather than defense. It has lost much of its importance when Penang changed its position from a military base to civil administration in 1898. During the 1920s, the fort had been occupied by the Sikh police of the Straits settlements. The fort has lost some of its original structure except the gunpowder magazine, a Christian chapel, cell rooms, flagstaff, harbour light, and several cannons. It has double walls, outer and inner walls, on all its 4 sides, which is not its south and west zones. However, in the early 1970s, the double walls on the west zone, including the main entrance, were demolished to give way for the city's sewerage system and electrical equipment. Instead, an iron fence and gate were placed along the west zone. In the early 1970s, several additional structures had been erected inside the Fort Cornwallis, including a modern amphitheater, souvenir shop, and toilet to promote cultural activities and heritage tourism. Since then, the fort has become a popular destination among the local and foreign tourists.
Structural defect of Fort Cornwallis. In the earlier of restoration project of the Fort Cornwallis, dilapidation survey were carried out in the order to identify structural defects, their location and possible causes. Some of the major structural defects discovered at the fort were cracks, leaning walls and collapsed walls. Cracks, either major or fine, were common defects found at the Fort Cornwallis. Major cracks were found on the top of the south zone wall and more obvious at the corners of the wall, whereas fine cracks were found mostly on wall and more obvious rooftop of the Christian chapel. Structural investigation showed that these cracks were caused by local settlement, water pressure, microorganisms, growth and erosion of mortar joint, as well as constant traffic vibration. Major cracks were also found to have related to broken brickwork that were caused by weak structure or poor mortar joint. Wall surface were also affected by erosion of mortar joint, which was caused by air pollution and the growth of the microorganisms.
Our analysis for this case study is based on the structural defect identified on the Fort Cornwallis. A few structure analyses were conducted on existing building material and structure in order to identify the component and strength respectively. The structural analyses involved were X-ray fluorescence analysis, compressive strength test, and foundation load test. Results gained from structural analysis of existing building material and structure were formulated to rectify such structural defect. Analysis for number 1 is X-ray fluorescence or XRF. The X-ray fluorescence analysis involved a total of 9 samples of the existing building material, namely all mortar joint, cement top, and wall plaster. The purpose of this XRF analysis was to analyze the component of this material. Result of the analysis had shown that the sample had relatively high content of SiO2 and CaO, of which helped in preparation of a mixture with appropriation of lime plaster, fine sand, and red clay that matched the existing building material. The closest possible mixture that matched the existing mortar joint, cement top, and wall plaster were used to rectify any structure defect. Next is compressive strength test of red clay brick. Most of the old red clay bricks used on the fort wall were handmade and were of different size. The old brick measured between 20.3 cm and 24.7 cm in length and between 9.0 cm and 12.7 cm in width. Several comprehensive strength tests were carried out on selected brick samples taken from each side of the fort walls in order to ascertain the strength of the existing red clay brick. The test result had shown that the compressive strength of the fort clay brick was mostly higher compared to Malaysia's normal standard of clay brick. Compressive strength, which is 14 Newton millimeter square, had shown in figure 3. The last analysis for this case study is foundation load test. The purpose of the foundation load test was to validate the strength of the remaining structure found at the west zone after the excavation work, so that any rectification such as reconstruction activity on the existing foundation could be undertaken. As the wall on the west side of the fort have been demolished earlier, several load tests on the remaining structure, mainly the wall foundation, were carried out for the purpose of reconstructing the demolished wall. 6 different points of load testing were identified along the existing wall foundation to ensure their strength in supporting the load. Of the wall. The true load and bearing capacity was derived from the loading of the existing wall by measuring the area of the wall and the block self-weight. The minimum test load was maintained for 24 hours and time settlement reading was continuously monitored and recorded. Loading was released gradually and the rebound reading were later taken. Throughout the excavation work, the old fort foundation were found embedded about 1.5 meter beneath the ground. Results shown that the total residual settlement taken from 6 different load tests ranged between 0.7 ml and 3.36 ml. Example of the load test result taken from one of the 6 identified locations is shown in figure 4. Failure shall be considered when the total residual settlement after removal of the test load exceed 6.5 mm or the total settlement under the design load exceed 12.5 ml. Results from the load test indicated that the foundation of the west zone walls were structural, sound and capable of supporting a new wall structure.
Action taken. Number 1. Major and fine cracks. Fine cracks on wall surface and rooftop were rectified by pouring a mixture of lime plaster and water into the crack using Petercock method. Such method requires the use of the empty bottle that has rubber tube underneath. Upon placing the mixture into the bottle, the rubber tube would be inserted onto any fine cracks to allow the mixture to flow and fill up any capillaries of fine hole in the wall structure or rooftop, mainly at the Christian chapel. For major cracks which involve broken brickwork, the brickwork were carefully removed and replaced to reinsert to their original position. In the case of weather or crumbly mortar joint, repointing method has been undertaken. Accessory pointing of major mortar joint was carried out by ranking out the decayed mortar joint at the depth of between 25 mm and 40 mm, followed by refilling the joint with the closest possible mixture of lime, sand, red clay mortar, which was prepared based on the result derived from the X-ray pollution XRF analysis. Number 2, learning walls. In order to restate the learning walls into their original position, the wall jacking method was used. This is in view of minimum disturbance to the wall structure. The first step taken in the method was removing 60 to 75 cm deep of earth behind the learning wall, while ranking short were used to provide temporary support to the learning wall. This was followed by several 10 cm diameter of hand-drilled concrete piles at about 25 cm interval behind the learning wall. The wall were later pushed and jacked gradually to their original position before filling the empty trench behind the learning wall with earth. Once the wall were reinstated to their original position anew, fold were fixed at lower level of the wall for the purpose of reducing interval water pressure. Number 3, collapse and demolish wall. To establish their original structure, all collapsed and demolished walls were reconstructed using thousands of salvaged red clay bricks. About abandoned old Traces house in Georgetown, built between 1962 and 1928, as well as salvaged red clay bricks from the Fort Cornwallis itself. Reconstruction was carefully done by laying down the salvaged bridge according to original brickwork. Prior to this, the salvaged red clay bridge from the abandoned Trace house had been tested for their compressive strength. Results had shown that all of them had a high level of compressive strength ranging from 25.0 Newton per mm to 47.8 Newton per mm, which compatible to the compressive strength of the existing red clay bridge found at the Fort Cornwallis.
Next is conclusion. There were a number of building and structural defects identified in the restoration project of the Fort Cornwallis, including major and fine cracks, leaning walls and collapsed walls, as well as demolished walls. Although the fort suffered several major structural defects, its original form and shape are still maintained. Upon identification of the structural defects, several structural analyses were carried out on the existing building material and structures in order to identify their components and strengths. Such analysis will be important for the purpose of structure rectifications. Solution for the structure defect of the Fort Cornwallis has been discussed, which involved proven technique and method such as Peter Cox method, wall jacking and reconstruction. Hence, the defect structure has been reinstated to their original form, positions and look. The works done on the Fort Cornwallis involved restoring and maintaining the existing building materials and structures that has been defective. All restoration works carried out at the Fort Cornwallis involve only on defected structures with minimum disturbance. The proven technique and method applied in the project were in accordance with international guidelines and principles of building conservation. Professional inputs and advice from the experts and consultants involved, particularly from the structure engineer, were equally important as to ensure the structure of the Fort Cornwallis last for as long as it could. Next is conclusion foundation failure. Foundation failure occurs when the structural integrity of a building foundation is compromised, resulting in various issues such as cracks in walls, leaning walls, collapsed walls, and other structural problems. This failure can be caused by a variety of factors, including poor soil conditions, improper construction technique, or natural disaster. It is crucial to address foundation failure promptly to prevent further damage and ensure the safety of the structure. Depending on the severity of the failure, the appropriate step may involve reinforcing the foundation, repairing or replacing damaged areas, or even completely rebuilding the foundation. To determine the extent of the foundation failure and the best course of action, it is recommended to consult a professional engineer. They will assess the situation, identify the cause of the failure, and provide recommendations for repairs. Finally, foundation failure can significantly impact the stability and value of a building, so it's important to take it seriously and seek professional advice to minimize the potential risks and ensure the building is able to survive in the long term.